You know, blood clots are a real biological paradox. Think about it. On one hand, they're basically the body's natural superglue, stopping us from bleeding out over a simple paper cut. But on the other hand, they can be silent killers, the culprits behind devastating heart attacks and strokes. So how in the world do we manage that delicate balance? How do we keep the helpful clots while fighting off the dangerous ones? Well, the answer lies in a pretty powerful arsenal of modern medicines. And that really brings us to the core question, doesn't it? Are blood clots our saviors or our enemies? The truth is, they're both. It really all just depends on where they form and why. The challenge for medicine isn't to get rid of clotting completely. I mean, that would be a total disaster. It's to control it, to keep it in check. And this slide just illustrates that duality perfectly. Over on the left, you've got a good clot doing exactly what it's supposed to do, forming a scab, healing a wound, absolutely essential stuff. But then on the right, you see the dark side, a bad clot, what we call a thrombus, that's formed inside a blood vessel in the brain. It's blocking blood flow and it's causing a stroke. It's the same biological process, but with a night and day difference in the outcome.
Okay, so to really get our heads around how we fight these bad clots, we're going to break it down. First, we'll look at the problem itself, when good clots go bad. Then, we'll meet the three main types of drugs that take them on, the preventers, the busters, and the anti-clumpers. And finally, we'll put it all together and see how doctors choose the right weapon for the job.
So let's start with the problem. Clotting is without a doubt vital for healing cuts and scrapes on the outside of our bodies, but it becomes a huge, life-threatening issue when those clots, called thrombi, decide to form on the inside, in our veins or arteries. They basically act like a roadblock, stopping blood from getting to critical organs like our heart, lungs, or brain. All right, our first line of defense. This is a group of drugs called anticoagulants. I want you to think of these as the proactive security guards for your entire circulatory system. Their whole job is to stop dangerous clots from forming in the first place, or, if a small one is already formed, to keep it from getting any bigger.
Now, here's a really important point. You often hear these called blood thinners, but that's not really accurate. They don't actually thin your blood. What they do is interfere with the clotting factors. These are specific proteins in your blood that set off a whole domino effect or a cascade to form a clot. So these drugs just make your blood less likely to start that cascade.
Now this is really interesting. Let's look at the two classic anticoagulants, heparin and warfarin. Just look at the differences here. Heparin has to be injected, but it works immediately. Warfarin, on the other hand, is a pill you can take, but it takes a few days to kick in. That difference in speed is absolutely critical. Heparin is what you use in the hospital when you need to stop a clot from growing right now. Warfarin is for a stable, long-term protection that a patient can manage from home. And that's really the bottom line. It's fast action versus long-term protection. If someone comes into the ER with a dangerous clot, they're probably getting heparin for that immediate effect. But if they need protection for the next few months or even years, they'll be going home with a prescription for an oral drug like warfarin. So when are these preventers actually used? Well, they're crucial for conditions where there's a high risk of a clot forming. This includes things like deep vein thrombosis, or DVT, where clots can form in your legs. They're also used after a heart attack for patients with an irregular heartbeat called atrial fibrillation and for people who have artificial heart valves.
Okay, on to our next class of drugs. What happens if a dangerous clot has already formed and it's blocking a major blood vessel? Well, that's when you call in the heavy artillery, the thrombolytics. These guys aren't about prevention. They are the emergency response team.
Their whole job is right there in the name. You've got thrombo, which means clot, and lytic, which means to break up or dissolve. These drugs are designed to actively go in and bust up existing clots to get blood flowing again as fast as humanly possible. This is a pure rescue mission. And this distinction is just so important. They are curative, not prophylactic. What that means is they treat an active, ongoing crisis. They don't prevent a future one. You would never take a thrombolytic to prevent a heart attack. You were given one right in the middle of a heart attack to try and stop it in its tracks. And the situations where they're used are, as you can imagine, the highest stakes medical emergencies you can have. We're talking about an active heart attack, a massive clot in the lungs, which is called a pulmonary embolism, or a stroke that's caused by a clot in the brain. In these scenarios, every single minute counts, and these clot-busting drugs can literally be the difference between life and death. And that brings us to our third and final category, the antiplatelets. So, if anticoagulants work on the protein clotting factors, these drugs work a step earlier. They go after the tiny cell fragments in our blood called platelets. The platelets' job is to rush to an injury and form the initial pluck. Antiplatelets basically just make them less sticky.
So their strategy is totally different. They don't stop that whole clotting cascade like anticoagulants do. Instead, they prevent the very first step, that clumping together or aggregation of platelets. By stopping that initial plug from ever forming, they can head off a dangerous clot before it even gets started.
So let's take a look at the most famous antiplatelet drug of all, aspirin. How does it work? It's actually pretty elegant. When platelets get activated, they produce a chemical called thromboxane A2. You can think of this as a signal that basically shouts to all the other platelets, hey, come join the party and get sticky. Well, aspirin just steps in and blocks the production of that signal. No signal, no clumping. Simple as that.
And from a scientific standpoint, this is the key. Aspirin permanently shuts down an enzyme inside the platelet called COX-1. By doing that, it basically removes that platelet's ability to make the get sticky signal for its entire lifespan. It's an incredibly targeted and effective way to get the job done.
So where do we see these drugs in action? Well, a lot like anticoagulants, they're used for long-term prevention. They are an absolute cornerstone for preventing a second heart attack or a second stroke in patients who've already had one. They're also essential for people who've had stents put in their arteries to stop clots from forming on those new devices.
Okay, so we've met the three main players in this fight: the preventers, the busters, and the anti-clumpers. But how does a doctor actually decide which one to use? Well, it all comes down to matching the right drug to the specific danger that the patient is facing at that moment.
So let's just bring it all together. If you have an ongoing risk, like that irregular heartbeat, atrial fibrillation, you need an anticoagulant for long-term prevention. If you're in the middle of a life-or-death emergency, like a heart attack, you need a thrombolytic to bust that clot right now. And if you're trying to prevent something bad from happening again, like a second stroke, an antiplatelet drug is your go-to for proactive, long-term protection.
So there you have it. Three very different strategies, all aimed at this same enemy. Each one is an incredibly powerful tool that has saved countless lives. But, the science never stops. The goal is always to find drugs that are even better, even more effective, and have fewer side effects, like bleeding. And it kind of leaves you wondering, what's the next chapter going to look like in our fight against these deadly clots?